Hi everyone, in this video we'll take integrals in four trigonometric functions. So you have to memorize the rules of integration of all trigonometric functions. So the integration of sine is negative cosine, integration of cosine is sine, integration of secant square is tan, integration of cosecant square is negative cotan x, integration of secant tan is secant, and integration of cosecant cotan is negative cosecant. So in part A we have the integration of 3 cosine x plus radical 7 cosecant square x. So this integration equals to 3. The integration of cosine is sine. So we have 3 sine x plus square root of 7, and the integration of cosecant square is minus cotan x. So here you have to put minus cotan x plus c. In part B, the integration is 1 over 7 because this is a constant factor, and the integration of secant square is tan. So we have tan of y because the variable in our integration is y, minus 4. The integration of secant tan is secant, so secant y plus c. In part C we have this integration, and as you know, sine t over 7 we can rewrite it as 1 over 7 multiplied by sine of t. So the integration is equal to 1 over 7 integration sine of t is minus cosine of t. So you have to put negative cosine t, then minus 6 integration of cosecant cotan. This is cosecant cotan, and the integration is negative cosecant. With negative outside will be positive cosecant of t plus c. In part D we have integration cosine u tan u, and as you know we can rewrite tan of x as sine of x divided by cosine x. So you have to prepare the integration firstly, then you can perform the integration. So we have cosine u, and tan u we can rewrite it as sine u over cosine u du. Then you can cancel cosine with cosine, and you will have integration of sine u, and the integration of sine is negative cosine. So the answer is negative cosine u plus c. And for the last part in our question we have part E. In part E, integration of 5 sine x cotan x, and cotan x equals cosine x over sine x. So you have to prepare the integration firstly, and you have to write it as 5 sine x cotan x, write it as cosine x over sine x dx. Then you have to cancel sine with sine, and you will get the integration of 5 cosine x. 5 is a constant factor, so you have to put it firstly, then you have to integrate cosine x, and the integration of cosine is sine. So we have 5 sine x plus c. In part F you have to prepare the integration, so you can rewrite it as integration of minus square root of 3 plus sine squared of theta, and you can rewrite cosecant of theta as 1 over sine theta. d theta. Now you can cancel sine theta with power 2, and you will get integration of minus square root of 3 plus sine of theta d theta. Now we can start to evaluate this integral. So this is equals to, the first term as a constant, so the integration will be minus square root of 3 times the variable theta. Then we have sine theta, and the integration of sine theta is minus cosine theta plus c. And in part G, you can rewrite secant x as 1 over cosine x. So you have to prepare the integration firstly, minus 5 cosine square of x, and secant of x, it is 1 over cosine x dx. Now you can cancel cosine x with power 2, and you will get integration of 7x minus 5 cosine x dx. X, it means x to the first power. Now you can evaluate the integration, and you will get 7x squared over 2 minus 5 integration cosine of x is sine x plus c. And in part H, you have to multiply secant y by all terms inside the bracket, and you will get integration of secant y cosine y minus 5 secant y tan of y dy. Now secant of y, it is 1 over cosine y multiplied by cosine y minus 5 secant y tan y dy. Now we can cancel cosine y with cosine y, and you get 1 as a first term inside function. So the answer of this integration, the integration of 1 is 1 times the variable 1 times y, which is y, minus 5, and the integration of secant y tan y is secant of y plus c. In part I, we have integration 5 dy over secant of y. As you know, secant of x equals 1 over cosine x. Also, cosine x equal 1 over secant x. So move secant y up, and you will get cosine. So integration 5 cosine y dy. So the integration equals 5 multiplied by the integration of cosine y, and the integration of cosine is sine, so we have 5 sine y plus c. In part J, cosecant of x is 1 over sine x, which means sine x equals 1 over cosecant x. So move cosecant x up, and you will get sine x. So we have integration of square root of 7 sine x dx. So the integration equals to square root of 7 multiplied by the integration of sine, and the integration of sine is negative cosine x plus c. In part K, we have cosine and denominator, so send it up, you will get secant. So we have integration of 3 secant x, also multiplied by secant x dx, and we can rewrite it as 3 secant square of x dx. Now the integration of secant square is 10, so the overall integration is 3 tan x plus c. In part L, send sine t up and you will get cosecant. So the integration will be integration cosecant square of t dt. And the integration of cosecant square is negative cotan x. So we have negative cotangent x, sorry, t plus c. In part M, you have to prepare the function inside before you start solve this integration. So you can rewrite the integration inside as cosine of phi over sine of phi multiplied by sine of phi d phi, and this is equal to integration of 1 over sine phi multiplied by cosine phi over sine phi d phi. And 1 over sine is, as you know, cosecant. So we have cosecant of phi and cosine over sine is cotangent of phi d phi. And as you know, integration of cosecant cotan is negative cosecant phi plus c. Now in part N, you have to distribute 3 cosine x for all terms in numerator, and you will get integration of 3 secant x over 3 cosine x plus 7 cosine x over 3 cosine x dx. Now you have to simplify and you will get cancel 3 with 3 and move cosine x up. You will get secant. With secant in numerator, it will be secant square of x plus cancel cosine with cosine and you will get 7 over 3 dx. Now we are ready to evaluate this integration. So the integration of secant squared is tan of x plus the integration of 7 over 3 is a constant, so you have to put the same constant multiplied by the variable of integration, which is x plus c. With the same manner in part O, we have sine x in denominator and you have to distribute sine x in all terms in numerator, and you will get integration of cosecant x over sine x minus 2 sine x over sine x dx. Now you have to simplify more, move sine x up, you will get cosecant. With cosecant and numerator, you will get cosecant square x minus cancel sine with sine in the second term, you will get 2 dx. Now you can perform this integration. So this is equal integration of cosecant square as negative cotan x minus the integration of this constant will be the same constant multiplied by the variable of integration plus c. And the last part in our question is the part P, and to solve it you have to simplify or prepare the inside function. So we have integration m squared minus m to the negative 1, and here send cosine square m in numerator, you will get minus 5 secant square of m dm. Now we can start to evaluate the integration, and you will get the integration of m square is m cubed divided by 3 minus the integration of m to the negative 1 is ln of absolute value of m, and we have minus 5 integration of secant square is tan, so we have tan m plus c. And this is the end of our example, and that's it. Thank you.